supposed to go live until I hit the button, but well, it is what it is. So here we go. You guys will be able to see this as well, and I'll be able to keep kind of an eye on stream health and do all the things. Don't have my fancy overlays and all kinds of other things going on, but you'll be able to see what's going on. So what I want to start for you guys is I want to go ahead and start on a couple things. Let's do a little more simply first, because there's tons and tons of different projects here. Couple things first. So let's do a quick example of a calculation. So it will definitely be coffee time, more so. So this is where we're going to start for today. And as we're getting started, now that I've got everything finally configured and have a workaround set up, go ahead and in the chat let me know on a scale of 1 to 10 how much fun you're having today with the LMS being broken. That'll be great. Scale of 1 to 10. 10 being the most fun you can possibly have as a human being, and 0 being the LMS is completely broken and we can't get into class today. All right, lots of 10s. Yeah, good thing you guys can actually do all the things all at the same time. So it'll be really confusing to try and watch the live stream at the same time, but a couple of you will at least get a chance to see what's going on. So what we're going to do is go through a few different simple commands and do another couple examples of some quick math as far as how we set some things up. So this is just establishing our gravitational constant. This is setting up our time array. So this sets up a time array with from 0 to 100 with steps of 0.1, and this is in seconds, the way that we're configuring it here. This is our actual formula. So does anyone recognize this particular formula? So this is telling us something about 1/2 times gravity times time. Now we have an interesting notation here for the math involved. What I want you guys to be familiar with is how we can use these what are called bitwise operations. So these are things that are going to be very, very important for a number of different factors. So the bitwise operations, what that's going to do is the bitwise operations are going to be a little bit different than some of the other things that we have available. What this does is this allows for us to do, instead of just doing this, for instance, we have to do element-wise is the correct terminology here, not bitwise. That's a C thing. We're in MATLAB and I need more coffee, and that's just the way today is rolling. So element-wise calculation on arrays. So these are another couple really important kind of fundamental principles. There's something that you will have seen on the on-ramp, but you may not necessarily have had all of the bits and pieces that you are looking for. So one of the things that we're trying to keep in mind here is we're trying to keep in mind we're trying to keep in mind that we have a couple different pieces to how the formula works. So this is the first part of it. This is half gravity times time squared. This is a result of the math that's involved, because we look at acceleration and we look at velocity and we look at, so the acceleration itself is just g. We integrate once from acceleration. So this is acceleration. This is our first integral. Of g with respect to time. So this is the second integral with respect to time. So this is position and this is velocity. So acceleration, the integral of that is velocity. The integral of that is position, right? Because the second derivative of position is gravity. This is the way the math works, right? So this is where our formulas come from, and that's why you guys know this formula, but you don't know why you know that formula, because we don't talk about it extensively as a result of this. So the position is 1/2 times the acceleration times time squared. But if you do it this way, what you're going to get if you go to try and run this, and we'll get to some of the other plotting commands and trying to understand how to make some of these things plot and behave reasonably, you'll see a very big difference here with the carets. It'll throw an error here. So let's take a look at what that looks like in the actual errors. So I'm going to go ahead and set up a breakpoint since we've learned how to use this. I'm actually going to turn this one on and say, let's run in advance. So it's going to come up with an issue right here. So let's take a look at what it's telling us. So it's telling us incorrect dimensions, raising matrix to a power. The problem is you can't just turn around and raise a matrix to a power. Does anyone remember why? Does anyone remember why? Can't raise a matrix to a power. Anyone? Bueller? No? So you can't raise a matrix to a power because they aren't the same size often. If you were to have something, a 3x3 matrix, for instance, you can get away with squaring that, but that's generally not what we actually want. We want to square the values inside of the array instead. So what we want to do is we want to go in here and do element-wise operations, and that's what it's recommending here. So each of these operations need to be element-wise like this so that we can correct this issue. So we can then go back in, do run in advance, and it won't throw an error here. We can step to the next step and verify that it's actually done the calculation up here, and then we can go to the next step and we can continue on. So it'll come up with a whole plot and all of these things, and so we'll look at the plot here in a little bit, but we're not quite there yet. We're going to do some other things in here as well. So this will make things pretty interesting. So this is our first part, and then we set up in order to do some of the kinds of math that's involved here. We're going to have to do some integration and some other things. So here, what we're going to have is we're going to have a couple operation called transposing. This essentially turns them on their side. So if it was a column vector, what I want you to see is what this data looks like. This will be pretty long, but I want you guys to actually be able to see. So we'll do the fancy pinky out style and use the display command just because. And what I'm going to do is I'm going to step out of the debugging mode and see where, all right, it should be done with the debugging mode now. Interesting. So I should be able to now run this like normal. Clear all, quit the debugging mode. So this should allow me to run it just like normal. Interesting. MATLAB is giving me a fun and interesting process. And I don't know why it's going to another step here. But what this will do is, oh, because I've got my because I've got my text box open, so now I'm cleared from this, and I will rerun this. So when you have a text box open, we'll get to this in a little bit. It will prevent you from rerunning things. So let's take a quick look at what these look like. So instead of being arrays, as in a one row and like 1001 column array, this one, if you wanted it to be exactly 1,000, you could start it at 0.1 and do some other things like that. There's some other little features that you would be able to use there. But what you can do is you can actually plot some of these. I'm going to get rid of the display M because we don't need to see it. The point is the transpose builds this array and goes down here and says, okay, we're going to grow, and then calculate. And so we've got T transpose. That's our very, very first one. So that's here. We've got our T transpose, and this is 1.0 times 10 to the fourth. So these are all reduced in the way that they're presented here as far as the numbers. So you have to multiply each of those by 10 to the fourth to get to the actual number. Anyway, this gives you an idea what that transpose looks like. So it takes a matrix and it turns it on its side. So it now becomes a whole bunch of columns, and sometimes we need to transpose something because we entered it as an array. But when we think back to the problem that we were working on just earlier, for example, for AX times B, we needed that X matrix to be a 1 by 3, meaning it had, or a 3 by 1, a 3 row, 1 column matrix to be multiplied against a 3 by 3 matrix of our variables, right? So there's a bunch of little things there to pay attention to. So another thing to pay attention to is, so we're going to go ahead and I'm going to comment this out because I don't actually need it. So we have our transpose the matrices. This is a way that we can create, this is also creating a new matrix out of those transposed matrices. And this is another kind of data storage and data processing that you can do. You transpose the matrices into a new matrix that is 1001 in this case by 3, because of how our operations work. So this is 1001 by 3 matrix now that we can generate using this kind of data. So this turns out to be really useful for a lot of different kinds of applications, a lot of data processing. We're not going to go super deep into all of the why for right now, but what I also want you guys to do is see the plots. So there are a couple things there that I want you guys to be able to take a look at. So the plots will allow for several different things to happen all at the same time. We started to kind of look at this, and again, if you guys have slept since then, you can always go back and say, wait a minute, I need to understand more about this whole plot thing. So you can take a look and see, okay, what we've got is this XY business, but the instructor keeps putting all these XY pairs in there. You can put in a significant number of XY pairs. I don't know what the actual limitations are, but you can put in more XY pairs in the help than actually even makes any kind of sense to the eye by the time you're done setting up all of the line specs and the XY pairs. So the plot function allows you to do lots and lots of really useful things. We're also going to learn how to create labels for the plots and some other things here before too long. But this is just trying to get you guys to understand how to do some of the kinds of data manipulation that you need to be able to do. So another one that we're going to use is this input command. And this is where the program was stuck for a second or two because I was not paying attention to the command window, which is always a bad choice in MATLAB. Also further evidence that I need more coffee this morning. The command window will give a couple different things all at the same time that allows you to do input as well as to do print statements. So input allows you to get keyboard input or user input, and so that's what this does. So if we go run this again, what we will get is this will be cleared. There's a couple more struggling to log in here. This will be cleared. So what this will do is this will allow us to do a few other things. Got a bunch jumping in here. So those of you, as you're connecting to audio, those of you just joining us, this is being live streamed to the YouTube channel so that you guys can go back and look at it later, because broken LMS is just literally the greatest thing on planet Earth. So the lesson that we're working on here is a couple examples talking about element-wise calculation, how to set up some of these kinds of calculations. We just got to the point of input, so I'm assuming that LoudCloud is probably just now this instant not under maintenance for another few seconds. So it should be no small comfort to you guys that LoudCloud is broken equally for everyone. So that's amazing. There's not like a secret professor side that always works. It just is what it is. So right now where we're at is input. The rest of this lesson up to this point all has been streamed to the channel, so you guys will be able to go back and review that. I'll have to make a quick edit on the first part of it just to trim out a couple pieces, but that's everything else should be okay from there. So we're at the input point for this particular code, and what we're going to do is we're going to generate, we're going to ask the user for something. So the input command, again, if we're not familiar with something, we do help on input. This one, come on, resize, let's go, let's go. What the input is going to do is it's going to give us a couple different ways that we can do input, either expecting a value or a prompt, and that's a thing that will require a lot of different kinds of interactions here. So we have some value that we're using, some variable that we're storing information to. So in this particular case, we're just looking for the user to hit a key in the way that we've set this prompt up. It can be some kind of input. You can set it up in this way. You can request numeric input, store it to a variable. So they have a bunch of good examples that are written out, so you guys can go back and see how would I set up in MATLAB some of the same kinds of things that we've looked at as far as some decision trees and things in Arduino. So that's also a thing that'll be helpful. So the link to the channel is posted in LoudCloud. I don't have the link handy to be able to drop into chat at the moment, but it is linked in LoudCloud along with Dr. K's channel. So PV and PX are a couple values that we're going to use. I'm going to use PX to be polyfit data for X, meaning position. So this is a way that we do a lot of physics kinds of calculations. The way these formulas work, again, gravity is the acceleration term, so this is distance per time squared. First integral of that is velocity, so acceleration times time. Second integral with respect to time is 1/2 times the acceleration times the time squared, but it has to be element-wise because of the way that matrix math works. You can't multiply a 1 by 1,000 by 1,000 by, you can multiply a 1 by 1,000 by 1,000 by 1 because those inner dimensions are the same. You can't do it the other way around where you have a 1 by 1,000 times a 1 by 1,000. That's not a thing. That's not the way matrix algebra works. So we have to be able to use these the way that they're set up. So print statements instead of serial print lines in Arduino. These are more C-like fprintf statements. So they're a little bit different even still than what other C code you guys might see. But fprintf allows you to print things to the actual screen. And so we have a couple more here that we're using. So you also have to use if you want, for instance, new lines and other things, you have to actually use these C commands like the /n. So this is, again, you want to always be referencing the help. And every time I'm asked questions about this, I'm going to first point you guys back to the help. In the same way that you guys normally use Google, except you actually want to use the help function built into MATLAB. So we have a few different things that are going on all at the same time. One of which is you have your prompt. So you contain some kind of a string, but you have a bunch of special characters, and those are defined. I think they have a bunch of definitions, yeah, down here below. So if you're also trying to include, information in the print statements and characters, you have to have the identifiers, flags. You can change some of the other things like the field width, number precision, character type, etc. There's a whole bunch of different things. Most of the time, you're going to use something like assigned integer, which is going to be a %d or %i. Either of those is fine. You can do a %f if it's floating. Those are, for the most part, really most of what you need to, but all of them are laid out here in order to see what each of those look like. So it's important to note that the %d is not like a double or something like that. It's a just another value for signed integers that you can display. So they explain a bunch of different operational characters and how some of this stuff works. And all of these characters, if you need backspace, there's a bunch of different things. The /n most of the time is what you need. The single quotes you can use inside of these things to actually have quotes. So these fprintf statements can be very convoluted as far as trying to work through them for the first time. So this is why I'm going to tell you guys all the time, go back to help, go back to help, go back to help, go back to help. You're going to get sick of me saying it, but that's the reason that it's there, is so that you guys can exercise your superpowers of reading comprehension and be able to get answers to how do I print out information? How do I get something printed out? And so each of these is a value. Each of these characters is a value. And the value that's printed to those characters is stored in A. In this case, A being an array, what you get is you get a value, and this is 96 bytes is the size of that particular array. So if you were to display that, this is what you would get. So a bunch of different examples laid out how you can use these characters to print variables to from an array A. So some value, some calculated value, so an x-y pair in an array, and then how can you display those things. The fprintf can take care of things like this, which are much more sophisticated than any kind of print statement that you would have been able to use in Arduino, but this is why a lot of this will be helpful. So there's all kinds of things that you guys need to be able to know as a result of some of this. So this will help kind of get you familiar with how to do a couple simple operations. In this case, I'm starting a new line. I'm giving some kind of text, and then I'm ending the line and going to the next one, so that when it prints the next statement, it's going to, in this case, I could end this with a new line, but for the purposes of what we're trying to do, I'm just trying to do some kind of input, and so in this case, I'm just looking for some keyboard input. It doesn't necessarily have to be the enter key. Then the fprintf comes in and asks or states what the next step in the program is. So what this does is this tells us, so this print statement tells us how far our program is working. So if we see this print statement out, we know that it's working up to this point. Then it does a calculation. So this is a kind of a manual method of troubleshooting code, a little bit different than running through and stepping individually line by line through the debugger. This is another method that we can use just as an indicator to say, hey, I want information fed back to me, and see what happens. So this is another thing that you guys will need to be able to do, is export that data to a CSV file. So the CSV files will give you a whole bunch of information about how these things work. So we're going to talk about that a little bit more here in a second, but we want to get through kind of what these print statements are doing. So those of you just logging in, a whole bunch of things going on today, including loud cloud wreckage and sinkage and floating to the bottom of the ocean. This has all been live streamed up to this point to the channel. I'll have to make a quick edit on the first couple seconds of the video as everything got launched, because it was ready to start streaming right before I actually hit the go live button, but is what it is. So at least it should have sort of passable audio, and all of the rest of this lesson will be contained there. So the polynomial fit parameters, this is what we're using. So polyfit we've talked about just briefly in the previous class. Polyfit is something that's very, very, very useful. So in this case, we're doing a third order polynomial fit to t and x, and this is just an example. So v should be something like a single order fit, because this is of a specific form. So if we're doing polyfit for velocity, what I'm going to do is do velocity. I'm going to use their little shift enter trick to move this so that this isn't confusing and you don't think this is an abbreviation for polyval or something like that. P velocity is a few other things here going on. So we've got this for the first part, we have polyfit, and we're going to go, instead of our equation up here being fit to a third order, which won't work considering this is of the form x equal, or in this case it's of the form y equal constant times x squared. Our fit should be of what order for position? Anyone know? What order should our fit be for a polynomial to fit x properly? I'll give you a hint that this isn't correct. This is what we've got right now. Should be second order for this. And what about this one? What about the velocity? What form is that equation? The velocity is of the form y equals mx plus b, so it's of the linear form. So what that tells us is this velocity is equivalent to a first order or linear behaving equation. So what we want to do then is we want to do a print statement, and we're no longer displaying our values for m. So we're going to do a print statement. We're going to do a couple things here, one of which is we have our equations that are going to be filling these two arrays, so x and velocity. So then we're going to print these out and say the fit parameters are %f, %f, %f. So these are all characters that are floats, so we can get decimal values for px and p velocity. So the polyfit for all of those. Then what we can do is we can store, since we generated up here another process. This is kind of trying to teach you a whole stack of things all at the same time in a program. We stored the transposed matrices T, X, and V from our calculations. We stored all of those to what's called a CSV file using this CSV Write command. It's pretty straightforward what that one does. So that one starts with a 3x3 magic matrix and sets things up as their example there. What it can do is store all of your information to a file that you would recognize as it's a comma-separated value file commonly used in Excel. So Excel will immediately recognize that file type. It's easy to import that data into Excel and do other operations. Why you would want to do that once you finally learn how to use all the power of MATLAB, who can say, but that's what this is. So that's what the CSV Write command does at the very, very end of this. So let's rerun this with a better ordered fit and see how this works. Let me see where my plot comes up here, because it should do the plotting. This one. All right, so we've got our, we're doing the plotting on X and then V for T. So actually that is actually correct. That one is actually operating correctly. The fit equations would now be correct. So we would be able to show that we can plot both of those on the same ones. The way that we would do that is we would start this plot and then we would do hold on, do these other calculations, and then do another thing. So that'll actually be a good example that I'll go ahead and set up. So plot, I am getting literally blown to smithereens with notifications right now. So I know there's a bunch of issues with Loud Cloud and other things and other communications. So we'll try and get through as much meaningful content as we can here. When we do a lot of plot operations, typically we want to come in and do some kind of a hold on, at least if we want to do operations on the same plot. And that's one of the many things you guys need to be able to learn how to do and learn how to do really well. So what we're going to do, this tells the plot to pause and wait for more instructions. So we can plot additional things on the same chart. And in this case, what would make sense is we go ahead and do the rest of our input and the rest of our things. So down here, I have to come down because we've got our enter key down here. So let's take a look at what the window looks like before. So this is what our window looks like before. I'm going to comment out this line because for the purposes of this class at the moment, that's making things fun and interesting. All right, so we're through our plotting here and all of our various factors. This one also I can see needs after this one we need a new line here. I can see just because our stuff's all bunched together on the same line here, and that doesn't need to be the case. All right, so we commented out the input line because we don't need that, strictly speaking, for this kind of program. I'm just trying to get you guys to see a bunch of different facets of how to write programs with different interactive elements so that you can get information to the user and then get information back from the user to use in calculations, do all kinds of other things. So once we've done a hold on, we can do another plot, and we can do that even after our CSV Write or wherever else, so long as hold on. So we're going to note here that the plot is still holding on. This now, we would still use T, our same X range, but now we're going to use our PX. And now we're going to use our P vel. But we need to specify how we want those to show up, because it'll just overlay those as new lines if we let them. So what we want to do is we want to do a line spec for each of them, and that means we need our single quotes, and we need to do something like maybe let's do red crosses for X, because that seems to make sense, and then let's do circles in black. So this is something that, again, if you guys don't remember, you go back to the help. Again, you guys are going to get sick and tired of hearing go back to the help. But at the bottom, you'll see more line spec parameters, color codes, and other things you can do. Here we go. So circles and crosses and a color. So red in one case, black in the other. So these are the short names. You can do RGB triplets. You can do, as far as I remember, you can do custom RGB codes, but then that gets to be a whole lot of work. So I won't punish anyone with something like the cyan or the magenta so that your eyes aren't bleeding at the other end of this program. So we would plot this, and then at the end, we need to never forget to hold off. So we need to hold off. And now when we run this, these need to be the same range. Oh, because these are my fit parameters, and I would have to do polyval. Polyval correct, because these are the fit equations. So let me add in, that's actually a good thing to cover as well. So let's do fit x equals, and then fit y, or fit vel equals. So we're going to do two of these. One of them is going to be for fit x, we're going to use polyval. So again, polyfit, polyval, things that we're going to use very frequently. And then we're going to update our plot to use our fit x and fit vel. So our polyval, again, we do what? We go back to help. What does polyval need? Needs the polynomials, the coefficients, the p's from polyfit, and the x values. In this case, our x values are time, so we use our px as our p values up here. So this is coefficients. Coefficients, 2 F's, 1 F's. Everyone gets an F. It's too hard to spell this morning. This is calculating cofs above, same deal. This fits from the coefficients above. So time, no caps lock, come on. And our p velocity and time. So our polyval will do our fit x and fit velocity. This now is actually the right size because our px and pval are these arrays that have just a little tiny bit of information. It's a 1x2 double. In this case, it has 2 pieces of information. In this case, it has 3 pieces of information because of the order of the equations. So Those are ways that we can do sanity checks on, hey, wait a minute, do I still remember which compass direction is north? So when we rerun this, we actually get this thing. So if we zoom in, and we zoom in, let's just zoom into this little pocket right here. We can see we have our original line and our fit line, and our original line and our fit line in black circles. So a lot of interesting things that we can do with these just the same way that we have otherwise. So we should be able to zoom back out. Anyway, the fact of the matter is we can use these parameters, especially going back and forth between polyfit and polyval, to get our not only our coefficients but also get our actual values calculated, our fit values calculated, so that we can plot, in this case, position versus time, and then velocity versus time. So this gives you kind of a broad range of different things that we can do and different kinds of outputs that we can use here that are, I think, pretty helpful overall. So the next question becomes, even though this last print statement has a /n, we still don't get the command going all the way to the next line. So that's an interesting curiosity. All right, so we have our two fit parameters and have everything set up. So what questions do you guys have on some of the structure of how this works? I'm going to set up breakout rooms and give you guys a little bit of time to kind of work on this. Sounds a lot like radio silence. I want you guys to see if you can actually get it up and working and plotting. In case you're still trying to get caught up here, I'll try and display as much as I can. That'll be easiest if I undock this window real quick. Bring it back over. So this is about as much. I think this is actually as much as I can show of that. There we go. So I want you guys to see if you can get this to work correctly. Make sure you don't have any spelling errors or anything like that at the moment. And then I want you guys to see if you can play around with especially things like the polyfit and polyval to change, even just to change the equations that we're using, and see if you can get it to plot another shape, something like a parabolic shape, something like X might be otherwise. All right, so I'm going to go ahead and set up breakout rooms. This code, this is a bunch of general principles that's going to be helping with several things you guys are going to be doing as far as writing and saving information, developing things for CSV files and a whole bunch of other things. There are a bunch of different principles that we have to learn kind of all very quickly in the context of the different assignments. So there's a bunch of stuff that's coming up here really quickly where you guys are going to have to be able to do data fitting and a bunch of other things. So that's why we're really hammering how to do data fitting with a bunch of different varieties, so that it doesn't matter whether you've seen the equations before or not. You will understand how to recognize, oh, this equation is of the form of a polynomial of the third degree, fourth degree, whatever it is, and I know how to use polyfit and polyval to get a graph out of that data set so that I can do other things with it. So this code will be helpful to some degree with some of the coming assignments. So I'll go ahead and set up breakout rooms real quick, give you guys a few minutes, and I'll kind of jump into them and see if there are more specific questions, and then we'll move to an extension of this since we'll have just a little bit of time to do so. So let's go ahead and do that. And here we go. So many different controls. All right. There we go. So those should be open now, especially since only about 2/3 of you are here.
I'm sure like half the class kind of just gave up on trying to get into the class. My code's working just fine.
Okay. Any questions?
No, not right now.
Okay.
Still
making sense how some of these equations are able to be used and how you can use polyfit and polyval to do some of these?
Yeah.
Yeah.
Okay. All right. I'll go check a couple of the other rooms real quick and see how they're doing, and then we'll switch over to a little more complicated example, or at least one that does a bunch of additional things.
All right.
All right. How's this room doing? You guys have any questions, or is this feeling pretty straightforward so far?
Well, no questions yet. I'm still getting it all typed up. If I have any, I'll let you know.
I'll try and keep an eye out. We'll work on another example here pretty shortly. I just wanted to make sure that everyone's actually sort of following along instead of getting lost and there being all kinds of crazy issues. So, yeah, lots of stuff we're trying to balance this morning. All right, I'll check a couple of the other rooms real quick. All right, how are you guys doing?
I'm a little lost just because I was not able to get like the first 30 minutes of class, but I'm just kind of going through it and figuring it out.
Okay.
Yeah, I think I'm missing some stuff from the top, like what G is, and other things, like it says it's missing variable.
Yeah, G is, so yeah, a couple of you guys dropped in a little bit late. G is 9.8067, so it's just gravitation, and up at the very top, CLC and clear, and of course your authorship information, and then there's 100% not enough coffee on planet Earth to fix today. So there's that. I don't know if it brings you guys any comfort that this whole thing is the process. There's just so many moving pieces today. It's a bunch of the instructors are having catastrophic behavior on the other end, so that's super fun. All right, so yeah, we have gravitation. This velocity is the first integral with respect to time. Position is the second integral with respect to time, which is where these constants come from. And it has to be operated element-wise, because you can't just square a matrix, because if you try and multiply a 1 by 1,000 by a 1 by 1,000, that doesn't work with matrix math. It literally doesn't work that way. The inner two dimensions have to be the same. Number of columns, number of rows. That way you can actually do the math that's involved.
What about the apostrophes after the T, X, and V in the M matrix? What is this for?
These are all a process called transposing. So what those do is, if we look at and we unsuppress that output and run this, what we have right now, these are arrays that are of a certain length. And what that does is that allows for us to do a few different things, including do operations. The trouble is, we are often not, when we're generating things, we're generating them as arrays with lots and lots of columns in a single row, typically, because that's the way that it's set up to take advantage of a bunch of these operations so that we can make very large arrays with simple code. The trouble is, a lot of times, something like that might be your X variable that you then have to multiply by the matrix or whatever. So you have to be able to do a transpose, meaning to tip it on its side and make it in this case, the M, what we have is we have this 1,000 by 3 matrix. So we took the T values, and that's all this first column. So incrementing by 0.1 all the way down to 100. Then we have the second column is in our code here, our second column is X transposed, and so X is also an array, but here it's a bunch of rows, single column. So we now have an X column, and so we can store data in this way so that we do lots and lots of calculations, and we just have to keep track of which direction we need it to be going in order to do the multiplication, division, etc. that we need to do in order to get the results calculated.
Where did you just open up like that spreadsheet?
So that spreadsheet, once I've run this and I calculate it, that shows up on the right side in the workspace. So I can click this value, and what this does is this shows me the actual table information. I can open as many of the workspace variables as I want to. I can take a look at fit velocity, I can take a look at fit X, what those parameters look like. So again, here is a good example. We did a calculation and it does it in a linear array. So all columns, one row.
Okay.
Same thing for this, and that's the way a lot of calculations default, is all columns, one row. So however many columns long the data set is, times, and it's all by one row. So a lot of times we need to transpose those to store them in something, or something is stored like this in a column, and we need to do linear operations where we have to calculate on them as if they were this way. So we have to do a transpose before we can do the element-wise multiplication. We can still do an element-wise multiplication so long as we tell it that we have to do it this way, but a lot of times the operations happen mathematically by column because of the way that matrix math works. So we have to transpose things all the time in MATLAB, and it starts to become second nature, especially once you've actually had a little more exposure to this whole process. So does that sort of help answer a couple of the initial questions?
Yeah.
Because we covered that a little bit at the early part, but not in tons and tons and tons of depth.
Yeah, for some reason mine only has like the 3 zeros up at the top. It doesn't have the the rest of the matrix.
So if it's calculating, If it's calculating from the size of t, and t is actually an array from 0 to 100 with a step size of 0.1, you should have a lot of data.
Yeah, I fixed it. I had a semicolon instead of a colon on one of those.
Yeah, so that will make a very, very different sort of size. So yeah, that'll make a difference. Yeah, so that should help get at least this first example kind of set up and functional. So this is a lot of seemingly random information thrown at you, but I'm actually teaching you guys a bunch of very selective, very important things in MATLAB, kind of all at the same time, so that you will be ready for all the wide variety of things you're going to see in the coming assignments, because you guys are going to get hit by a lot of new and strange things very fast in the coming assignments. So I'm trying to make sure that you guys are getting some of the meat and potatoes of this. All right.
Thank you. Mm-hmm.
Any other questions?
I think I'm fine.
Okay, Liz, you doing all right? She's not even in here. Macy, you doing all right? Max, you doing all right?
Yeah, for the most part.
Okay, any other questions at the moment?
Not right now.
All right. I'll give you guys a couple more minutes to work on it, then we'll jump back into the main room and keep trucking. All right, we'll start getting coffee rolling. We'll do a couple things here in the next block. All right. Get in the habit of all right, there's a couple more pieces that'll be helpful. Okay. I think we're ready for everyone, so let's do that. Those of you that are following along on the live stream will probably be a little confused, but that's okay. I've only got about 2/3 or so actually in class today. All right, we'll wait for a few more seconds as everyone jumps back in. All right, we're only waiting on a couple now. So, a couple things that you want to include. So this will be another different other example. A couple things that you guys want to include on this will be how to make some of this stuff work. I need to make the Loud Cloud maintenance my new screenshot. That'll be great. Couple things that we need to be able to see are we need to be able to see how this whole thing operates. You want to make sure that you've got some kind of information about authorship. You want to make sure you have some kind of title. That way you can start recognizing and distinguishing some of your code. You want to make sure you have authorship information, all the things, and then you want to start out with setting up your workspace, closing out other windows, because a lot of times you'll have multiple different examples. So let's go ahead and go back to screen sharing so you guys don't look at me like I have 12 heads, because that's a fairly common side effect of teaching online. Alright, we want to set up our command window and clear our workspace and do a couple of other things. So I want to make sure all of these pieces are lined up. We can do an example of a couple different ways to use the /n and some other things like that. There are a couple elements to some of the coming assignments that we're going to be working on where you're going to have to use things like methods to calculate distance from the origin, as well as a whole bunch of other moving pieces. And so I'm not going to give you all the fine details of how all of these will work, but I'll go over a little bit of an example that you guys can see. So what you'll need, for instance, if you're doing a distance calculation, this is another really good activity to do, is the x1, y1, x2, y2 pair. You can ask, what is that? And then store it to x1 as a variable. So this is a very clean way to get input from the user, store it to a variable. Sort of like what we were starting to do. This can be fairly interruptive, but one of the things that you can also do is add some additional print statements for the sake of general clarification. Things like, are you still alive? Then you can get information. You can say, what is x1, what is y1, what is x2, what is y2. So you can assume that things are, for instance, a range of things from 0 to 10. And I'll give you some hints about the logic here. So if x1 is less than or equal to or greater than or equal to 0, and to do multiple logical conditions in MATLAB, you can get away with single ands, but I want to show you what message it'll suggest when you do this. There are single ampersands, but it will give you a warning here, and it may run some of the time, but you want to get in the habit of double ampersands because the arguments are scalars instead of actual just Boolean operators. You want to use double ampersands if you're trying to do multiple sets of conditions. So this would look at, this is going to be the way that we do nested if statements in the context of the code. So we would have if less than, so x1 is greater than 0 and x1 is less than 10. So if it's in the range from 0 to 10, so it can be equal to 0, can be equal to 10, and y1 is greater than 0, greater than or equal to 0, and less than or equal to 10. So this is how we check two different conditions, or two different ranges. If those are between 0 and 10, then do the next thing. If this is between 0 and 10, then do another thing. And a whole bunch of other pieces that you can include in the logic there. Then you do stuff. So this will not give exactly all of the key differences away for one of the things that we're going to try and do, but it'll get you guys kind of into the mode of thinking about how to approach a complex problem. So what we're trying to do is we're trying to set up a method to calculate the distance from the origin to both sets of points. You're trying to figure out the line between these pieces of information. So right now we're getting the information, we're setting up the logical range, and we're doing the if statements and doing an end. So we have to end if statements in MATLAB, and we can use a layered set of conditions. So if both of these are between the range of 0 and 10, then we can execute this. So right now we don't have an else statement, because if this condition is not met, technically we should have an else that has some kind of a print message that says values out of range, we're going to crash into the planet, or something helpful and useful in an error message like that. So we want to use the way that these work. We want to use a couple different features, and we want to be able to say, all right, so this, you can plot these points. What we're going to do is we're going to set these up. This is explaining what we're actually trying to do. So we're plotting x0, y0, and x final, y final, these points on the graph. And then we're saying, all right, so we want to start by, in this case, we haven't done any other plotting yet. There's some other stuff that I've stripped out of this example. So you can start with hold on. You don't technically have to until you've done a plot of something. So this gives you, once you've done the hold on, you can plot x1 and y1, x2 and y2. You want to use distinguishing characters. I recommend using symbols rather than leaving it to be lines, because the symbols are going to be a little easier to distinguish than lines are. And then the final plot with all of these and your distinguishers for y1 and y2. So this is plotting the line from x1, y1 to x2, y2. So this is how to take 2 points of any kind and actually plot them on, and actually plot the line between those 2 points, because these two are just points. If you just plot those are 2 individual points. So what does this actually look like when we run it? If we said 3, 4, and we do 8, 9, then we get a plot that looks something like this. So I want you guys to try and see if you can get this to work as an example. This is kind of stripped down to be very minimalist in its use, but this will give you a way to recognize which point is which, and then the dotted line in between those, so that you can see how it calculates distance. And it will tell you there are ways to calculate distance from the origin. This particular one doesn't calculate the distance from the origin. This is an extension of what this can do. This is just the actual mechanics of the plot for some of the things that you guys can do to get used to, again, some more features that you can do with figures. So I'll give you guys a little bit of time to work on this. As I go to open those rooms again, questions on this part. This is another seemingly random series of things that I'm throwing your way, but they all actually go together and have a purpose. All right, I'm not seeing any pop-up, so I'll go ahead and reopen rooms.
almost.
Alright, what are the questions you guys have in this room? Some of the stuff making sense, or am I still completely speaking in mostly Martian?
I give it a 50-50.
Okay. This, unfortunately, the last part of this class is going to feel a lot like this, where we're doing things that are going to seem much more complicated than what we've done earlier in the class. There's not much that I can do about it, because one of the last assignments tries to point you guys to object-oriented programming in MATLAB, which is learning how to generate classes and do all kinds of things that are actually pretty sophisticated. So, trying to get down a lot of the fundamental math operations and make sure you guys can use some of these higher level features in MATLAB to do real things. So there's no real major questions, it's just mostly a matter of trying to figure out which end is up.
Yeah.
Okay.
I have an idea. So yeah.
Okay. Well, it's a good start. That's at least not completely left on the side of the road for dead like the instructors that I had. So it's a starting point. All right, I'm going to check in on some of the others. All right. How are you guys doing? What questions have you guys come up with?
No questions so far
Okay.
for me.
Have the rest of you reached peak understanding? I've achieved enlightenment and I should retire now?
Understanding it pretty well.
Okay. A lot of it will start to make sense, I think, especially with a lot more practice. So that's one of the big keys for all of this. There's a lot that we have to do in MATLAB, and you guys have to learn a lot of things very quickly, so that's why we're not spending lots of time trying to just do simple, easy examples. We're trying to make sure you guys actually have the grit to actually work on your homework, because there's a bunch of difficult aspects to that.
Right.
Alright, I'm going to check on the last room real quick. We're going to be out of time pretty quickly today. So I just want to make sure that I'm trying to address questions and making sure you guys have access to this after the fact. Alright, how are you guys doing? You guys making sense of this now?
I think so.
Okay. The nested if statements and levels of logic with simultaneous comparators is more complicated than stuff we've done in the past, but it's just kind of an extension. So we're trying to get you used to the idea that a lot of the stuff that we're doing is going to be much more sophisticated in MATLAB, but you have a lot more sophisticated helps and other things available to you. So there's that. Max, you doing all right?
Yeah, I'm doing good.
Okay. All right, I'll give you guys another couple minutes, and then we'll come back into the main room and see if there's any remainder of questions, and then we'll close out for today. I'll bring everyone back. So we're still waiting on the last couple. All right, we've got a couple other things. There's a couple times where audio drops off and does strange things on the stream. I think the video has been fairly continuous, but I don't have any of my fancy overlays and stuff set up in OBS at the moment, so have to deal with what we've got. All right, so as the last couple join us here, any other questions from today or questions about some of what we're doing in MATLAB today? Any points that are like notably unclear for you guys? Or is it all feeling at least kind of within reach? Is it sort of working more than less? I mean, it's probably working better than the LMS is this week, so there's that. All right. Well, it sounds like there's at least not mass confusion, so that's a good start. In that case, I'll go ahead and let you guys go just a few minutes early, and I'll go ahead and turn off the stream and a bunch of the other stuff and try and get things configured so that you guys can go back and review this. Because of all of the fun and excitement, that also likely means we'll have some issues with classes tomorrow and later on. So I'll try and sort out some of the issues as best I can, but I can't control the LMS being amazing. So if there's no further questions, then I will catch you guys all next week, I guess.
Thank you.
Thank you.
Have a good weekend.
Thank you very much.